So in this video, I'm going to go more quickly through each of these examples, which are more examples of percentage problems. And I'm not necessarily going to keep referring back to the other slides where I talked about the steps, but you should have that written down. And as we're going through it, compare to that so that to help you internalize what we're doing over here. So in this example, it says that a bill was $30 and the tax that was left was 60 cents. What is the percent for the tax, right? So you can see that I start with a diagram to try to understand this problem. And I know the original bill is $30, and so I paired that up with the 30%. I also see that the problem is mentioning tax, and I know that's an increase, so I set up the diagram to go to the right. I know that they gave me the tax. They gave me the actual increase as 60 cents. Right? I don't know why it says 0.60 here, just 60 cents. Now, since they gave me the tax, what they're probably looking for this time is the percent. And I don't know what that is, so I put an X up there because that's what they're looking for, right? So you can see how you translate from the problem to a diagram, but it starts by realizing what kind of problem it is. I knew it was a tax problem, so I knew it was an increased situation. And I knew they weren't giving me the percentage because they were asking for it, right? Now, I can do the is-off setup. I put the 100 in place first, then I put the X on what the percentage is because I don't have it. Then I put 30 on the bottom because that's my original, and 60%, 60 cents on the top because that's the part. When you cross multiply, 30 times x makes 30x, 0.60 times 100 makes 60. Next step is divide both sides by whatever's next to the x, so I'm going to divide both sides by 30. When I do that, the 30s cancel out, and 60 divided by 30 gives you 2. Now, because you're looking for a percentage, you have to put a percentage on your answer. So my answer is 2%. That's how much tax I had to pay. Make sure to write a percentage sign when you're looking for a percentage. But see, that walks us through the same steps that we did in the previous video. So let's do one more like that. So it says the tax is 8%, and that was $80, right? So what was the price of the bill? So notice that they're giving us the actual percentage as 8, and they're telling us that the actual tax was 80, but they don't know what the price of the bill was. So it mentions tax. So once again, I need an increased diagram. Any type of tax problem is always going to have like that. So then I know that the tax is 8%. So I put that on my increase. And I know that I paid $80 in tax. So that's the amount of increase. What I don't know is the original price of the bill, which is matched to my 100%, right? So if I'm trying to do that on the is-off setup, I always start by putting the 100 in place. Then I put my percentage in place. In this case, it's 8%. Then I put my whole in place. And since I don't know what the original price is, I put an X there. And then I put the part, which I know is 80. Then I cross multiply. X times 8 makes 8X. 80 times 100 makes 8,000. Then I divide both sides of the expression by the number that's next to the x, which in this case is 8. So 8x divided by 8 just cancels out. 8,000 divided by 8 makes 1,000. So this bill was $1,000 if I had to pay $80 when I paid 8% tax. So the steps are always the same. Make a diagram, set up an is-off, put the 100 in place, put the percentage in place, put the whole in place, put the part in place. Whatever you don't have, you put an X in there, and then cross multiply, divide by what's next to the X, and you get your final answer, right? Now, it does make sense, by the way, that the bill is 1,000 over here if 8% is 80, because 8% is such a small fraction of that $80, it does make sense. And so you always go back to the diagram, too, to think about whether or not that makes sense. So this was several examples of tax problems. Let's look at some examples of discounts. Now, remember, discounts are the other way around because we're talking about a decrease here, because decreases are when you're going to have less. So let's do a few of these problems. So there's a bill that's $120, but you get a 15% off coupon. What is the discount and the new price? So this is the most typical kind of discount problem you're going to see. Now, because it's a discount problem, I know I'm going to be decreasing. All right, so I set up the diagram the other way around. I know that my original value was 120, and I matched that to my 100%. I know my decrease is 15%, right? And so I know that I'm looking for that discount. Now, of course, if I want my new price, I'm going to have to get the total minus that price to get the discount. So I set up the is of, put 100 in place, then I put the percentage in place. In this case, it's 15. Then I put the whole in place, 120. I don't know the part, so I put an X in there. So always the same sequence. Cross multiplying X. X times 100 makes 100X. 120 times 15 makes 1800. Next step, the number that's next to the X, divide both sides by that. 100 is next to my X, so I divide both sides by 100. The hundreds cancel out. My answer is going to be 1800 divided by 100, which is $18. It does make sense for $18 to be a 15% fraction of 100. Now, if I want to figure out the new total, I got to get that original price and subtract the discount from it. So I do 120 minus 18 and get my new price is 102. So you can see that the process is the same. The only difference is that you're finding a discount. Let's do a few more here on this video about looking at discounts still. This time the bill is $300 and I got a discount that was $90. Notice I don't get a percentage this time because I'm actually asking you what is the percent discount. So I know my original was $300 and I know that I lost $90, but the discount is what percentage is what I'm looking for. So I put an X over there. Once again, I set up the diagram going to the left because I know a discount problem is one where I'm going to end up with less than I started with. Let's go to the is of setup. First step, put the 100 in place on the bottom right. Second step, put the percentage in place. Since I don't know what the percentage is, I put an X. Next step, put the whole in place. And I know the whole is 300 because it's paired up to my 100%. So I put that 300 in place. Next step, put the part in place. The discount is the part. So I put the 90 over there. Next step, cross multiply. 300 times X makes 300X. 90 times 100 makes 9,000, right? So next step, find out what's next to the X and divide both sides by it. 300 is next to the X, so I divide both sides by 300. The 300 will cancel out on the left side, and my answer will be 9,000 divided by 300. So the discount is 30%. Notice again, if I'm looking for a percent, I always have to put a percent sign in my answer. 30 is not the same thing as 30%. So make sure that whenever you are looking for a percent, you put a percent on your answer. One last problem here with discounts. So this time I know the discount was 10%, and I know that was $20. So what was the price of the bill? So here I'm looking for the original price. I don't know what that is, but I do know that I paid $20 less because there was a 10% discount. Once again, I set up the diagram going to the left because I know that I'm losing money or spending less money. So it's going to go down in value, right? What I have to actually spend. Let's do the is of setup. Always start by putting the 100 in place. Then I put the percent in place. In this case, 10% is what I'm looking for. Next, I put the whole in place. I don't know what the whole is, so I put an X there. Then I put the part in place. The discount is the part, always. So I put $20 there. Then I cross multiply. X times 10 makes 10X. 20 times 100 makes 2,000. The number next to the X this time is 10. So I divide both sides by 10. The 10s cancel out, and my answer will be 2,000 divided by 10, which is 200. That makes sense. If I'm getting a 10% discount, and that's $20, the total should be something like 200, right? And does that make sense? So you just have to use the diagram, follow the steps, and everything is going to be okay.